Yo, what's up, everybody? Welcome back. Today we are working on our PNG decoder, and today's topic is trying to take our absolutely broken decoded PNG and turn it into something reasonable. So, yesterday we kind of started by generating this little guy, right? A 107 by 77 pixel image. We tried to figure out how to read this thing, and we got like pretty far. Let's see if we can pull up the PNG spec. We kind of learned yesterday that there is. Why is this fucking frozen? God damn it. We learned yesterday that. Let's see. There are these like chunks of data in a PNG. It kind of like represents itself as. Let's see. We can just like read our parsing code and see what we learned. We have. There's like a header that says. Hey, I am a PNG, right? Kind of like this first like 8 bytes or something. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Then there's, I don't know, I don't remember what these are. I think this is, I can't remember. But then there's like these like blocks, right? And these blocks have like different meaning depending on what their identifier is. But the key ones here is there's a header, a data segment, and an end segment. There could be multiple data segments, but it's like, header, one or more data's end. In the data, there is some zlib compressed data, where the data kind of represents almost very close to an image, right? If we try to print out what that thing represents, or like the data in that thing, we get essentially this. There is one extra byte on the left side of this image. For each line, there's one extra byte, and that extra byte says, I am a filter. Like, how are you supposed to interpret the data within this line? So I think that is in here kind of talking about filter algorithms. And in some cases, they might say, hey, instead of looking at like the actual pixel value, could you look at the difference between me and the pixel before me? Or could you look at the difference between me and the guy above me? Or the average of like a few? Or a payeth? I don't know what these are. But in order for us to be able to decode PNGs, we have to apply these filters. And so that's kind of today's goal, is try to do that. Now, when I look at this, it is not really clear to me what it really means. We can make some guesses, but it's kind of hard to like verify if we're correct about those things. So like to compute the subfilter, apply the following formula to each byte of the scan line. Sub x, this is the formula, takes the raw value of this minus the raw value of the previous pixel. But I think that what I would like to do, instead of just trying to like run at this and try to like apply these functions and see if the image looks right, I would like to have some form of proof that we are interpreting this stuff correctly. And I think that in order to do that, it makes most sense to write a PNG encoder, right? And we can try to create an image that we can feed through these algorithms, and then feed that generated PNG to a decoder that's not ours, like a normal decoder. And if that decoder gives us back what we thought we fed in, then we are big chilling and we understand what these filters do. Some of these things get like a little bit complex, which is why I kind of want to look like. Like this payeth predictor is like whatever the fuck this is, right? And so once we understand that once we know that we understand the filters, then we can go back and we can implement them on our side. Now, you could say, why don't you just use a PNG encoder and then compare what you get to what you think you should get? Or like use a real PNG decoder and then compare your output to their output. And you could do that, except I would like control over our test cases. And so that's why I think it makes sense for us to write something out. Because once we have like our encoder, then we can do like a there and back again test with like very, very specific crafted data, right? Where we wouldn't be up to the whims of whatever the PNG decoder decides is the best filter. We can like force it to take a certain path. And so that's why I kind of want to do it that way. And so plan of action is we need to manufacture some PNGs from code. We need to like basically do the reverse of the decoding. Then we can start applying specific filters. And then once we have that, then we can fix our decoding. So we'll see how far we get. That's the plan. And let's just jump in. So we are at 0445. Oopsies. I didn't want to exit that. Okay. No number. Okay. And I guess, yeah, it's fine. Okay. So I guess we need to make sure here that we understand that we could manufacture this thing. So I think that we have like a pretty good handle on everything up until this point. I think that there is a four bytes of stuff that we haven't really investigated yet. So I need to double check what is going on there. It's probably a CRC of the entire file, like a checksum to make sure that everything's chill. And I would like to see if we can like confirm that. So somewhere in here in the specification, they have the file format, probably. Yeah. So PNG file structure. So he starts by looking at a PNG, like this is like the magic at the beginning that says this I'm a PNG, 1, 2, 3, 4, 5, 6, 7, 8 bytes. So that's the 1, 2, 3, 4, 5, 6, 7, 8, which means that there's 3 bytes after that, these 0, 0, 0 before the I header, which is the 4 byte. So it's probably this is the length, or maybe this is the length. Yeah, that makes sense. This is the length of the header. Then here's his name, and the data goes in here somewhere. Got it. And each chunk has a CRC at the end of him. And that's kind of it, I guess. I think it looks like. So I guess when we look at this, when we say I end has some stuff at the end, we're actually saying that I end has a CRC associated with him, which is probably just like the default initialized CRC. That'd be my guess. So if we're going to generate a PNG, we should be able to manufacture one of these pretty easily, but we have to like we have to CRC check everything, which I don't really know how to do. I'm kind of hoping that the standard library has a CRC generator so I don't have to make one, because I don't really want to look up the math right now if I don't have to. Oh, let's fucking go, baby. Okay. Oh. That's not good. That's a lot of options. So how does this work? So presumably these guys are all... I see. So we have like some parameters for a generic CRC thing. Presumably we want some sort of 32-bit CRC, and I guess we should read this a little bit. So chunk CRCs are calculated using standard CRC methods with pre and post conditioning. Okay. I don't see anything in here that says those words, so we'll have to read a little further. CRC polynomial employed is this. So I think that I think what I have seen before in this type of coding is this like funny math where you encode a polynomial like this where like each power here is like 1 bit is what I've seen before. So you can only have, if I remember correctly, 1 or 0 as your prefix to one of these things, right? So you can't have like 2x. You can only have 1x or 0x, and then the power here is like which bit it is looking at. However, this has 2 to the 0 and 2 to the 32, which doesn't fit in a 32-bit value. I would have thought, right? I thought that 2 to the 31 was the max that you could specify in a 32-bit value. Am I stupid? With 4 bits, you have 2 to the 1, 2 to the 2, 2 to the 4. Oh no, okay, you can. Never mind. No, 0, 1, 2, 3. Yeah, 0, 1, 2, 3. Yeah, so I don't understand where this 32 is coming from, but we'll see. And then I guess we can try to look at this polynomial for like the default CRC 32 and see, or maybe we can figure out if this is like a named thing. PNG CRC 32. Let's say if we just like kind of like ask for like a dumber version of this, maybe somebody will give us like a little bit of a simpler version. We'll look up CRC in here. Yeah, this doesn't seem to tell us any this doesn't seem to tell us, like, give us just like a word that matches something in here, which is about as far as I was hoping to, this is what I was hoping for. So we're gonna have to figure out how to construct this algorithm somehow. So there's some initial value, reflection, and XOR output. So what do they say? This is a 32-bit CRC register, initialized to all ones. Okay, so that means that there's initial value of 0xFFFFF, essentially, right? The data from each byte is processed from the least significant bit to the most significant bit. After all the data bytes have been processed, the CRC register is inverted. So that's the XOR on the output. This value is transmitted, stored MSB first. For the purpose of separating into bytes and ordering, the least significant bit of the 32-bit CRC is defined to be the coefficient of the x31 term. Okay. Sure. So we have lowest bit x31, and then practical calculation of the CRC always employs a pre-calculated table to greatly accelerate the computation. See sample CRC code, chapter 15. All right. Let's look at chapter 15 then. Make CRC table. This ED thing might be their initial polynomial. Who needs CRC check? SCB image certainly doesn't. Oh, that's a good point. Can we just dodge this by like, if he doesn't look at the CRC, okay, you know what? That's pretty sick. That's a good point. I just assumed that somebody would fall over if we didn't calculate the CRC, but if STB image just doesn't fall the fuck over, we can just not give a shit. That makes our lives significantly easier. Good eye, good eye, good eye. So can we start then with struct PNG encoder? And I guess that this is going to be maybe some sort of like, he's going to have some writer, right? Who's going to take in a comp time t type, return a type, who is a structure, who has a writer. SCB image and other SCB libraries assume the input is trusted and correct. Yeah, makes sense. Makes sense. And I guess we're gonna have like, I guess we need a writer like this. And we're gonna have like write magic. Okay. Who is gonna take whatever like that PNG header is. Cool. Okay. So this is just gonna be like writer write all of PNG header, okay? Then we're gonna have write block. Maybe we'll have write I header. And that kind of makes me feel like this has to come out. This thing is now like shared between the decoder and the encoder. So kind of like all of this stuff kind of comes up here, I guess. Okay. So then we can write a chunk who is going to have a chunk here. Okay. Seems reasonable. So we're going to go switch on chunk, I header. Is that how we want to do this? Yeah, sure. If we see an I header chunk, I guess we just write like stood writer write all stood mem as bytes h, I guess. I think before we do that though, we have to write out some of the extra fields. So on read, we have length type data CRC, right? That's what we're supposed to write. So we have to write the length type data CRC. So length is can we get like how do we like get the header? So they do like get the length, get the type, data CRC. So we write the length, which we need to extract from, I guess, size here. Yeah. And then we just say we switch on self, and on iHeader, it's return size of iHeader. IDAT, it's the size of the data, right? IEnd, it's 0, and unknown, it's return dlen. Okay, chillin'. So now we have the length. So we write out we want the native to big U32 of length, which is going to be chunk get size. Okay. That is the first thing. Type, we're going to do chunk tag name of chunk. So this is the type. And we're going to say, I guess we're just going to write all tag name of chunk. And I guess we'll, before we do this, ensure that we are not unknown. So it will say if chunk is equal to unknown, we'll just say here return error can write unknown chunk. Okay, that seems reasonable to me. We'll kind of, this could maybe be fixed later, but fuck it. Then we write the data. So on iHeader, we write this thing, except the endianness of this thing is wrong. So can we go like native to big struct? So this is going to be like this, and this is going to be native to big. So then we have write all native native to big struct. Okay. Here we write the data, and then on iEnd we do nothing, and on unknown we do unreachable. Cool. Cool. So then we've written then we just write the CRC. Which is 0, 0, 0, 0. Invalid CRC. But otherwise, that seems pretty reasonable. Why do I write stood right here? I just wasn't really thinking. And then I think that should be good. That should be good. So can we construct ourselves a PNG? So can we say that we're gonna go like output file, it's gonna be std fs create file, current working directory, relative create file, and it's gonna be like test manufactured PNG. Okay. We are going to get a write of that thing. Okay. And we're gonna try to create a PNG encoder. So which means we need like a function PNG encoder that takes in a writer of any type and returns a PNG encoder of type of writer. Okay. Which means that we should be able to do like writer zero writer, boom, chillin'. So then we should be able to do PNG encoder with output file dot writer. Okay. And this doesn't need pointer argument, like, it doesn't need to be mutable, I don't think. So we should just be able to go like write magic. And then we need like some data to write. So we're gonna do RGBA 8 byte, 8-bit depth. So it's gonna be like an array list of pixels, which means that this needs an allocator. Which means we need to import this thing. Okay, and we don't have a pixel yet, but we can make one pretty easily. So can we just do like const pixel equals packed struct RGBA? Okay. And can we start by just like, maybe we start by just making like a blue thing or something? I don't know. Const width is 100 and we'll make a height 50. Right, we'll alloc pixels of width times height, right? And it's actually width plus 1 because the first value per line has to be a scan, like the pixel code. So if we do like data dot mem set data with pixel r is equal to 0, g is equal to 0, blue is equal to 255, and dA is equal to 255. We then have to figure out, we go like 0 to height, right? For each of these, we are going to set a special thing of 0 for the first element on every line. So we're going to say data time at width time plus 1 times height is equal to the special thing of 0, 0, 0, 0. Okay? Times y, sorry, not times height. And now we should be able to just write this fucking thing out. I think we also need to compress the data. So we should just be able to call like real zlib c import c include zlib.h. And it should just be able to be like real zlib compress something source into dest. So compressed compressed len. Source is data pointer and data len. Quick question. I also love programming, but since the rise of ChatGPT, I literally cannot be bothered to type things out anymore. Instead, have to have it sketch anything out I want to build before I go in and tweak it to my heart's content. Isn't that way more fun and productive? What's your take on that? Would appreciate a non-ChatGPT sucks response. I mean, it does suck. I mean, that's the answer, right? Like, I know what I want to write. ChatGPT doesn't know what I want to write. He is not very good at like organizing things the way that I think they should be organized, and so I just don't use him. I use him for like, he's kind of like a dumbass, right? He's like a not very smart person with a lot of information, right? And so you like, don't get me wrong, he's very useful, right? You can ask him to like, if you're like looking for like, I want like an example program that does this thing, and there's lots of examples of that on the internet, he can probably like mishmash that shit together. But as soon as you're trying to do anything like a little more complex, I find that he kind of falls over. And also, like, he's wrong a lot. He's wrong. I feel like he gives me like an incorrect answer maybe like half the times I ask him anything, which maybe just means that I'm not asking him things very often, and I'm only asking things when I'm like kind of stumped. But like, he's wrong a lot. And so like, why would I take something that I think might be wrong with little context, right? If you ask him to like spit out a page of code, is it really easier to take what he wrote and adapt it? I think that starting with a pile of shit and then turning it into something better is harder than just starting with trying to make something better, right? So, I mean, take that with whatever grain of salt you want. I'm not giving you the answer you want because I don't think that's the answer that I want to get. Like, that's not what I believe. But yeah, I mean, why? Yeah, I just don't understand why I would start somewhere worse than where I want to. Okay. This is going to be pointer. I've wasted many hours because ChatGPT gave me the wrong answer. Anything I actually want to help on, ChatGPT failed miserably. That's how I feel a lot as well. I'll also say that like a bug, writing a bug costs so much time. So much time, and a subtle bug is very easy to write by a human or ChatGPT, right? And if you didn't write all the code, your intuition on where that bug is like even worse, right? So like, if you're trying, if like, it's often just faster to do it yourself, because one, a bug that you wouldn't write wouldn't slip in, and two, if you did write a bug, you might have a better idea of where you wrote it, right? So there's a lot of reasons to not do it that way. I'm not saying don't use ChatGPT, right? I use him not infrequently, but I find that the best places are for very simple things that I already know and just don't want to type out again, right? Like if I'm like, I want like a hello world triangle in OpenGL, I've written that enough times now that I know exactly what it should look like, what I want it to look like, and I can get ChatGPT to just like make the small tweaks that I want. If I'm like, just fucking like embed two triangles in the vertex shader, right? That's something that like I struggle to remember the syntax on, but I remember the concepts very well, right? So things like that I think he's good at, but yeah, I think asking him to write your code for you is like not a way for not a path to success. And I'm surprised. I mean, who am I to judge? But I am surprised that somebody who loves coding would prefer to do it that way. But I mean, that doesn't mean that you don't. I'm just saying that surprises me. We need some output buffer for this like compressed data. So let's just say that we're gonna like give it kind of like the same size as the input, kind of fuck it. And what does this return? What does it return? He returns z. Okay. So if this is not equal to real zlib z okay, we return an error where the error is error compression failed. And then once we have that, we should be able to write out a header for this thing. So we have like a header here is going to be I header. And what goes in this thing? This stuff. Okay. So we want color type to be 6. Bit depth to be 8. 8 bits per pixel. Width and height are simple. Compression method. What did we expect? We expect 0, 0, and 0 here. Okay, 0, 0, 0. So then can we say we want like our... Maybe we set up all our data, then do the writing at the end. So we'll kind of go down here and we'll go like encoder, write chunk. I header is equal to header. We write the data. I guess we can probably, this kind of looks better, I think, like this. We write one IDAT of the compressed data from 0 to, I guess we need like compressed len is equal to 0 here, is equal to compressed len like this, because this needs to tell us how much it compressed. And then we go from 0 to compressed len like this, and then we write the end at the end. And then that's it. That's like a PNG, theoretically. So can we just be like, write PNG alloc, and then if true, return. Appreciate your take either way. I found it extremely useful for OpenGL prompts too. Yeah, it can definitely be useful. I'm not saying that he's not useful at all. Error is ignored. Dude, the amount of times that I've seen people ask ChatGPT something that it cannot know, then take its answer for granted is very concerning. Yeah, I agree. I think that the level of confidence in it is scary. And I think also, as it improves, the level of confidence will increase, but it doesn't kind of... As it improves, I believe that the percentage chance of it being right gets higher, but it does not fix the problem that it will sometimes be wrong. And so, like, as it gets better, this problem gets worse, I think. Which, sucks. This thing needs to be a U8 pointer, I guess. So can we do, like, std mem bytes, as slice as bytes of data pointer like this. Seems okay. Right magic. These things need to be right to try here. And then we need to write all PNG header here. Wherever the fuck we use that needs to be ampersanded. Okay. Get size is mad at... Let me just do this. I guess here we'll like incast him here. That's fine by me. This is mad about native to big. Native to big struct H. What is the type of H here? What's the problem here? He's mad about like 262. 262. Yes, he's mad about this right chunk here. Because as bytes expects a pointer. Oh, I see. Because here we need like a big version of this thing is this, and then we need to do as bytes of big. Sure. Although he's still not really mad, or he's still not really happy. It's kind of surprising. Kind of surprising. I thought that works. Expand a pointer, optional, array, or vector type. Found U32. Am I fucking stupid? Yeah, I am. Data D. Not bad. Still mad. 263. So we're on right chunk header. This is mad about as bytes. Because we have the same thing here. big size is this. Oops, there we go. Data is idat, not data. Funny how people come into channels with people making like things from scratch and asking why bother typing stuff in. I mean, I think that's like not unreasonable, right? I think that if you're like, I do this thing that way, and you do this thing a different way. What's the like? What? Why are we different? I think that's like not unreasonable. You know, I think that's like fine. I end. He's mad. Do I really have to write out like? Can I write I end here like this? Does it autocast? Oh, I guess it does. And then 96. He's mad about what? Comp time ignored. I forgot to return here. Fine. Fine. Okay. So now this is mad about an out of bounds access, which is kind of surprising. So what's going on here? Our data size is, oh, oops. Oopsies, much better. Okay, so can we like test manufactured PNGs? Is this thing broken as shit? Yeah, so this thing is not good because his I header is invalid, it looks like. So what have we done wrong here? What have we done wrong here? Okay. Image format is actually PNG, not PNG, okay. And he's just spamming I header invalid, which is not very helpful. Not very helpful at all. But okay, let's look at this again. Filter. Oh, I think our filter method is wrong. Oh no, filter method has to be 0, which is what we wrote, I think. So reading this again. Reading the PNG spec again. Can we look at the RFC? No, I don't want this one. I want this one. Here we go. I header. Okay. So, hello? Where I clicked on I header. Where the fuck are we? Oh, here. It must appear first. It contains width, height, bit depth, color type, compression method, filter method, interlace method. Width and height must give the dimension in pixels. They are 4-byte integers. 0 is an invalid value. The maximum is this. Bit depth has a single byte integer given the number of bits per sample or per palette index. Valid values are 1, 2, 4, 8, and 16. Okay. Color type is a single integer that describes interpretation of the image data. Color codes represent the sums of the following value: 1, 2, 4. Oh, I see. 1, 2, and 4. Valid values are 0, 2, 3, 4, and 6. So we have 6, which is RGB triple, followed by an alpha sample. Sample depth is the same as the bit depth except the case of color type 3. Sure. So we should call it sample depth instead of bit depth. Compression method is a single byte integer that indicates the method used to compress data. Only compression method 0 is supported. Filter method is a single byte integer. Present only 0 is supported. And interlace method should be 0. Okay, so I don't understand why it's mad, to be honest. I wonder if we accept this thing. That'd be kind of fun to find out, wouldn't it? Looks like maybe we did not. Oh, hold on. Oh, this is leakies? Hold on. Oh, because we if true return like a dumbass. I forgot we closed that. Okay, so we actually do get mad here. It'd be nice maybe to look at the header. So we have 100 by 50, 86000. We're chilling there. But then when we start looking at this thing, we go out of bounds, probably because our data. Compressed. So here we go, width. Oh, because it's supposed to be width times height plus 1. And yeah. It's actually, we should do an alloc of U8s. Width times height times 4 plus 1. That's my bad, because the filter method is only 1 byte, which means that this isn't okay? Fuck, so how do we want to do this? We want to go like const scanline size is width times 4 plus 1. This should be scanline size times height. Okay. Then here we should be going like pixel data U8 is going to be a stud mat. We're gonna do like, we're gonna have like something like this, right? This is the color return, right? We're gonna go pixel data U8 is equal to stud mem as bytes of the pixel. Okay. Cool. Then we're gonna go for 0 to height. We're gonna say that data at scanline size times y is equal to 0. And then we're gonna go data from for 1 to scanline size. 0 to scanline size over 4, I guess. My guess here is that you could do something like data at scanline size times y plus 1 plus x times 4. Yep. Your guess is that you want to check something. That's a pretty good point. I forgot that we didn't do that. But this is also wrong, so this is easy to fix as well. We're going to copy from pixel data U8 into data start to end. Okay. Now, you're right that I think this will still be wrong. But here we are seeing our blue rectangle. So at the very least, we have processed our encoded PNG correctly. Will this guy? No, he won't because of the CRC, which I think you are correct in calling out. So can we open this thing with STB image instead? Or can we do like fe? Surely this won't care. Fe, ignore PNG CRC. Is that like allowed? Surely. Great. Can we ignore checksums? Maybe not. Okay, that's fine. We'll just open it with STB image. We'll look at it ourselves. We will look at it ourselves. So we're gonna do like read PNG. How do I want to test this? I guess I want to like pull STB image in. Let's start here. Perl-o this, and then what's our typical thing here? We do like edit source stb image.c so that we can go take this define and then include stb image.h We go to build, we say our exe now depends on that thing. Which says this comes from source stb image.c. And we also add that to one of the include paths. So we look at, is this thing takes in a lazy path? Okay. Which means that now we can call this. And then any Zig compiler dev here would be like, don't do it this way, but you can't stop me. Because this invokes LLVM twice, but you know, whatever, I don't give a shit. We can eat a little bit of compile time for a nicer name. And then somewhere, we're gonna be like read with stbi. And we'll call this like in. This is gonna be some sort of like path, I guess. In path and out path. Okay. This is gonna be stbi dot like load from file, load from path, I guess. In path, let's make this sentinel terminated so that we can just type pass the pointer in without having to worry about it. We get the width. Var width is a C int, and so is height. Okay, then we say channels in file, which we don't give a fuck about. We want 4 channels. And that's it. We get the data out. Okay. So then we're gonna kind of do this like write ppm here, which is gonna look a lot like whatever the fuck we have down here. Okay. But this is gonna have like data, I guess. And we're gonna go, we're gonna look at the stride. Okay. And I guess we're gonna have like width, height, and stride. Okay, so this is gonna go, we're gonna write the width, we're gonna write the height. We're gonna go from height, we're gonna look at data from y times stride. We don't have filter methods in this anymore, so we're just gonna go y times stride and start plus stride here. Or maybe width times 4 seems a little bit more correct. Data here, and then this stuff seems fine. Okay, so then we have a loaded image. We can just like write a ppm into test manufactured.ppm, and we need the data, the width, height, and stride. Okay. He's mad here because we actually have to write the file, so this is supposed to be write to out path. Okay, and then can we just call like try write ppm test manufactured PNG, or write, what was it? It's read with stbi, and this is ppm, and okay, there we go. And this will probably go here, to be honest. Manufactured PNG. Okay. Out path constitute weight, and this gets turned into out path. Okay. How's that feel? How's that feel? 317. He's mad because we can put a semicolon. Fine. He's mad because out path is not used because it should be out path here. Okay. And then loaded image is mad because it needs to go from 0 to width times height. Times 4, I guess. I don't know. Because we need to keep the right amount of data, blah, blah, blah. This thing needs an intcast here and an intcast here. Boring, but whatever. And probably one here as well, to be honest. So many intcasts. Error union is ignored, so we're gonna try here. And please call it a day. Nope, we are not quite there. 300. So this is mad because... Oopsies, what did I just do? He expected this, found that. That's fair. This can be constant. Oopsies. Okay, so he's mad at an attempt to use a null value. Which means that STBI load failed. That's kind of surprising. Yeah, that's pretty surprising. Pretty surprising. Loading. Loading this. What do we do wrong? And then loaded. And can we just like put the pointer value of loaded image? Is that allowed? Do I have to write any there? I don't know. He doesn't like that. Any? Okay, so yeah, he got a null pointer back. Loading this, ls this exists. So what's he fucking mad about? What is he mad about? Can we turn off CRC? Is it like actually CRC checking or something and I didn't realize? No? Can I get like the error message somewhere? Error, error, error. Oh. There we go. There's these like STBI error things. Okay. Oh, so this returns STBI error. How do I like get the error back out? This calls STBI error like this. Which does what? STBI error. Oh, here we go. G failure reason. Here we go. Failure reason. Nice. Nice, 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 nice. If loaded image equal null, we return error STBI load and stood log error the reason. So error loading image, and we'll log the reason here with STBI failure reason. Boom. All right, let's see what he says. Let's see what he complains about. Bad I header length. Bad I header length. Ooh. So how is that possible? We write the length comes from chunk get size, bit size of maybe? Maybe he's mad about like, there's like some sort of like alignment packing shit. No, still mad. Oh, that's surprising. Bad. I header len. Okay. Length is not equal to 13. Okay, so what's going on there? 4, 8, 9, 10, 11, 12, 13. Can we just like, what if I write 13 here? Error loading image for an unknown reason now? So what am I doing wrong here? What am I doing wrong here if we are not writing 13? Std debug print, writing this, this with size this. What have I fucked up? Because I feel like I must be misunderstanding something. So we're looking at tag name of chunk with chunk get size. Okay, let's start there. Writing iHeader with size 16, so that's not good. So there's a mistake there, sure. So get size, what if we do a bit size of? Okay. Over 8. Okay, which means that maybe this is a fucking problem. Right? So we kind of need to go like, we need to truncate this thing to 0 chunk get size. Probably there's like alignment issues here. And that's much better, so it makes it the end. It should be a packed struct. It is a packed struct, but the packed struct still has padding. So we need to use the bit size and not the like aligned size, which is fine. Right, we just have to make sure to like truncate this thing to the size of the actual data and like strip the padding out, which is fine. Not the end of the world. So it looks like this is working now. And then if I open this thing with whatever the fuck it's called, test manufactured PNG. So he's still mad because of CRC error, but that's an improvement for sure. But the thing that we wrote with STB image is in fact creating a blue picture. So that's good. We can now manufacture a PNG by ourselves, which is pretty big for us. So the next step here is I want to like, well, I think I want to make this thing a little bit more advanced. I think I want to make it kind of like a gradient so that when we convert there and back, any mistakes in the math will become very clear very quickly, right? So can we just do something like, okay. When we put the data in here, I want to do something that's like, we have y and x here. So we can just do like this. Okay. So the red value is going to be the maximum red value, okay, times the x value, okay, divided by the width. The green value is going to be 255 times y over width or over height. Blue value 0, alpha value 255. And I think that gives me, if x is 0, then this gets multiplied by 0. If x is maximum, this gets turned back into 255. So that should give us like a nice little gradient. Should. Can we... Oh yeah, nice. Oh, nice. And we actually see a CRC error, but it still actually works, which is cool. Now, the output ppm. Oh no, hold on. Oh, this is testmanufacturer.ppm. Wait, that's chill. That's chill. Testmanufacturer.png is mad, but that's okay because the ppm looks like what we want, which means that stp image loaded it and sent it back out correctly. Size of should give you the specified size, not including padding, or what throws it off. I think that that's not quite true. I think size of tells you the size of the thing when you put it on the stack, right? So you make a variable x equals 4. Size of that will give you like how many bytes it actually takes up. The packed size is different than the actual size than like what size it returns. The packed size is like if I were to put this in an array, then it becomes like kind of packed the way you would expect. A line of would give you hints about the padding, but a line of, I think that the alignment of a struct is smaller than the size, right? If you have a 20 byte struct with a U32 as the first parameter, the alignment is 4, right? Because it only has to align so the first value is correct. So there's like, that's why they give you bit size of, because the bit size of is like, okay, if we gotta compress this shit as much as we fucking can, that's what they give you. Okay, so we have a manufacturer PNG by hand. We've kind of done that enough that it works. CRCs don't work, who cares? Now we want to, can we do something that's like, segment this thing? Or maybe we'll just kind of overwrite one of the lines. Maybe we need like a source image to work with as well, but maybe it's fine. Yeah, maybe we want to create an image data is going to be like this. We're going to have image data is pixels. Then we'll set the data in the image data. So for 0 to width, we'll just say that image data at width yx is equal to pixel. And then when we actually convert this stuff, we can like reference that previous image data. This will allow us to like start applying the filters and look at like a buffer that is easy to work with to do the calculations. So here pixel data U8 is equal to image data. I guess it's a pixel here comes from image data at y times width plus height or plus x. And let's just see if that works. He's mad at inflate error. Oh, because we don't have, oh yeah, it should be fine. ARM test manufactured ppm, sig build, xg open test manufactured ppm. Okay. Yeah, so that still looks okay, which is good. Which is good. And then now we can start trying to apply these filters. So let's start by changing this thing to be 1 everywhere. And xg open test manufactured ppm. So he's actually mad about what? There's some leaks in here. We have an inflate error, but like, oh, right, okay. XGG, hold on. It's because something else is failing, but we can fix that later. So can we do like a if true return here for a second? Okay, so this is what we get if we stick a 0 at the front of each line instead of a 1, which is very interesting. Very, very interesting. So now what we should be able to do is we should be able to start constructing the stuff that goes in this filter according to the rules that it talks about, and hopefully that will help us understand what this filter is actually supposed to do. We can like prove to ourselves that we got it correct. So sub. A subfilter transmits the difference between each byte and the value of the corresponding byte of the prior pixel. To compute the subfilter, apply the following formula to each byte of the scan line. We look at the raw value of x. So far, are you writing this for fun, educational purposes, or because Zig doesn't yet have this? I don't really care if Zig has it because you can always use C libraries or like other libraries. It doesn't really matter. But how do I say this? Yeah, we're just doing it for fun. We just want to learn. Where x ranges from 0 to the number of bytes representing the scan line minus 1. Right, so this is a byte. This is working on like a byte level. So we take in any byte position in the line, and that is the input to x. Okay. Raw x refers to the raw data byte at that byte position in the scan line. Okay. And BPP is defined as the number of bytes per complete pixel. Sure. So what am I missing here? Sub x is equal to raw x. So x is a byte position here. Raw x gives me the data here. So this is so we're saying, okay, got it. So we're looking at the raw. We're looking at the pixel or the byte in the image buffer minus the previous byte. Now I assume that there's a special case for 0 here. Filtering algorithms are applied to bytes, not to pixels, regardless of bit depth or color type of the image. The filtering algorithms work in the byte sequence formed by a scan line. Blah, blah, blah. When the image is interlaced, blah, blah, blah. For all filters, byte to the left of the first pixel in the scan line must be treated as being 0. Got it. So for filters that refer to the prior scan line, the entire prior scan line must be treated as being 0s. To reverse the effective filter, the decoder must use the decoded values of the prior pixel on the same line. Okay. Sure. Yeah, sure, whatever. Or some other stuff. Okay, so if we want to use the sub method, we look at the pixel data U8 is going to be 4 U8s. That's kind of how we define this right now. And we're going to look at the previous pixel is if x is equal to 0, we get a pixel of r equals 0, g equals 0, b equals 0, a equals 0, right? They're saying no. Hold on, we're working at a byte level. Okay, so let's work on a byte level then. So we're going for 1 to scan line size, or maybe we'll say 0 to scan line size minus 1. We'll call this x byte, and I guess we should start at 1 here. So the scan line has like the first byte says what type of filter am I applying. The next byte is xb. X. So in order to look this thing up in the pixel buffer, we're going to look at image data. We're going to look at the image data at xb minus 1 times 4 plus y times width. Okay, this is the pixel we're working at, and we're going to say const byte val is equal to. No, this is not the pixel we're looking at. We want to look at that pixel as well as the previous pixel, I guess, which is annoying. None of this is straightforward. Can we look at like the pixel row as U8s? That's probably easier. Input pixel row U8. That seems nicer to me. Okay, let's start there. We'll start there. Could you use Zig to compile Rust if you added the Rust LVM front end? I don't know. I'm not even sure what you're asking. As you're asking if you could use the Zig build system to build Rust, I don't think that that's how it works. It's not like Zig is just like invoking LLVM directly, right? It's doing a lot of other stuff. It's running like a Zig front end and stuff. It can compile C code, but that's because it runs like it runs like Clang under the hood. I doubt you could do something similar with Rust. I doubt. Okay, so the pixel row is going to be the image data at height times width, y times width to y plus 1 times width, okay? This is the input row. And we are going to look at in pixel row U8 at xb. Yeah. That looks pretty good. So const this byte is equal to this. Prev byte is equal to this minus 1 unless x is 0. Then it's 0. Like it said in the spec. Cool. Now we have the pieces of info that we have here, that we need here. So we're going to essentially set like data at the output data at scanline size times y plus 1 plus xb, because we need to offset by 1 for this, for the format identifier or whatever, the filter identifier. This is going to equal, this is not prev byte though. So if xb, this is supposed to be offset by 4, right? That's what they said. They said offset by 4 because there's like 4 bytes per pixel. So if xb is less than 4, then we do this. Yes. I think that makes sense. And then this just becomes this b minus prev b. How's that look? How does that look? This needs to be stood mem as bytes, slices bytes. Oh, we're so back, baby. We're so back. That's looking pretty good. That's the correct gradient with a sub filter. Okay, so now if we do the same thing with 2, obviously it'll fall the fuck over again, right? That's fucking wrong. But we can kind of start working our way forwards here. So how do we want to do this? How do we want to do this? That's good. I guess we want to start doing something that's like filter method is going to be like y% the number of filter methods. So we're allowed 4. And I guess we'll just kind of like increase this as we go. Yeah. So if we are at 0, we do this shit. So we're going to go like this is like this. Yep, that seems reasonable. And here we'll put a comment and say, fix me enum, but this is sub. Oh, wait, this should be 1. 0, we just kind of put the pixels data in as is. I suspect we're going to want this row no matter what. So in the case of 0, we just kind of mem copy from the in pixel row u8 to out row u8 or something. So this is going to be out row u8 is equal to something that resembles this. Out start is equal to this. Out end is equal to out start plus scanline size minus 1. Okay, and then this out row is out start to end. Okay, which means that now we can just do data xb is equal to this. Yep. Oops, except that's on this one. This is like out row u8 xb is equal to this. And then on this thing, we just go mem copy for 0. There's no filter, we just copy the row out. If it's sub, then we apply sub. Does that still work? He's mad. Because what? He's mad because expected u8 found usize. Can we just write this? He's mad because mod doesn't know that %2 makes him fit in a u8 unconditionally. Else we write unreachable. Okay, sick. So now we have alternating lines. Out row start is okay. Whatever. I'll pull your thing over. This guy's saying this is easier for him to understand. I wish I could get rid of that like fucking pin thing. I think that's hard to understand for me. Right? Like, just write end is start plus len. I don't really. That's reasonable to me. Double slicing is hard for my brain to interpret if it's a 2-dimensional array or not. Right? Double slicing is like, double slicing to me feels like you're cheating. It feels like you're like, because when you do like x 4 5, like this is indexing a 2-dimensional array, and x 0 to 4 0 to 4, you can write 0 to 4 as many times as you want here and nothing fucking happens, right? And it's like, how come in this syntax you're going down a layer and in this syntax you're not? That's very, like, I find that like extremely confusing. And then it gets even worse. If you did want to do something where you're wanting to index into the second layer, you'd have to do something like this, right? Like, I don't know. I don't think it's like wrong. I just think like it hurts my head more, so I don't do it. Okay. So I think that this is a pretty good sign that we're understanding something. Let's try to. What happens if we look? Can we look at like what we would interpret this as? So if we do like I had an if true return here. And I think that this was broken for some fucking reason. Oh, maybe it's not. Okay, this is working. Can we look at output ppm? So this is what we would interpret this as. Right, so what you're seeing here is that every other line we are doing like direct put the stuff in, but every other line we're doing like give me a value relative to the thing to the left of me, right? Which is not working. So we can kind of start, we can like start implementing a fix for that very simply. Why is this commented out? I don't think that should be commented out. Okay, so for us to fix that, we have to look at the filter method. Oh, that's why, is because, right, so we have to switch on the filter method, which means that I want like a filter method enum, which I think doesn't exist yet. Can we do like a function filter method here as a self I header, comes out as a filter method, right? And we need to define a type for that. So this is gonna be like non-sub up average path, whatever the fuck path means. And we're gonna look at the filter method. And I guess we're gonna look at, I don't know why I'm doing it like this. It should be kind of more, I should be copying this thing. And this should be 0 goes to return this, and 1, 2, 3, 4. These get little dots on them. Doesn't double slicing get optimized away? I don't think it's like a problem. Like optimized wise. Like it's just like my mental can't fucking handle it. Return error unsupported filter method. Okay. And have I spelled return wrong? Return? No, what's the problem then? Oh, because I forgot the arrow. Okay. So now we can call filter method. Oh wait, this is wrong. This isn't what I want. Fuck. We want line filter method, I guess we'll call it. Adaptive, I think they call it. PNG filter type, maybe? Is probably the right word here. And can we do like from U8, I guess? Like this. And I guess this is like an optional. Stood meta ena or int to enum? Yeah. I think it's like this. Sure. Catch return null, I guess. Which means that now we can say that the filter type is equal to filter type from U8 of the scan this value. Maybe we'll extract the scan line like this. This and this. Scan line start plus scan line size again. Then here we can go scan line start to scan line end. Boom, boom, boom. And then we can say that the filter type is the scan line first item. Boom. Yep. And then we switch on the filter type. Yep. Okay. Seems cool for sure. And we're going to do something very similar to the encoding side for sure. So if you have none, we do whatever we were doing before. So can we say we do this, I guess? Copy the data out. So we are looking at the input data, which we have already. But we're looking for like the pixel data. So this is gonna be like scan line from 1 onwards, I guess, because we're stripping off the first byte. And we look at each byte in here and drop it in. Sure. Because the output of this thing is only RGB, not RGBA in our like output writer right now. Okay, if we have a sub, then what are we gonna do? We're going to have to take the like, we're gonna iterate over this thing, right? And we kind of have to work on a pixel by pixel basis. So we kind of have to do it this way still, which is a little weird. Because like what happens is like the filter is being applied to RGBA bytes, but our output is like dropping the A for our output file. Enum from int exists with an at. Yeah, I know, but that doesn't check for invalid values. Yeah, two steps got it. It's too loud for validation. Okay, so do I like it would be kind of nice to split this stuff up, I guess. But we'll kind of handle that later. So I guess we can work on the scan line. I guess. I don't really know. Var I equals 0 feels like it's gonna work here. We can do like while I is less than scan line len minus 1. Or y equals 1 and I is less than scan line len. Then we can go like, why is I shadowing? What the fuck is it shadowing? God damn it. Scanline IDX, I guess we'll call it for now, because I don't want to figure this out. This will all get refactored later, but we're just trying to get something. We're going to look at the scanline index, and we're going to say that the pixel index, oopsies, is going to be scanline index minus 1 divided by 4. Okay, that's the pixel index. Then we're probably going to do something for each byte in the pixel. Yeah, I guess. And what are we going to do? What are we going to do? Why am I looking at this again? Right, because the output has to be on a pixel by pixel basis. So we're going to say like output pixel is going to be, we're going to treat this as 4 U8s RGBA. And I guess since we're like skipping alpha because our output doesn't have alpha channel. And we're gonna do something like, I don't know, man. Scanline. I think we don't need to use the pixel index actually. Yeah, this is what we can do. This makes sense. So we're gonna look at the scanline of scanline index plus B. Yes. There we go. So this is current. Previous is going to be B minus 4. No. Current index is equal to this. Yup. Then the prev index is current index minus 4. And we should probably name bytes per pix is equal to 4 for now, so that it's easy to rename later. We actually have that somewhere already. Bytes per pixel. Does seem like we've already done that. Which, what do you have defined as? Oh my lord. Okay, 4 times bit depth over 8. Okay, sure. Sure. Well, scan. Okay, here we go. So we go scan line bytes per pixel. Yep, here we go. Scan line at we need to set the current thing. So right, so we're saying scan line current is equal to something. We need the previous value is going to be, we have to be careful here because these are unsigned integers, so this could fall over. So we have to do if current index is greater than bytes per pixel. Now we can do the previous value is equal to, greater than or equal to, less than or equal to. If this is less than this, we return 0 or 0, else we look at current scan line current IDX minus bytes per pixel. Yes, 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 yes. We got there. And then the thing is just, we have a current value as well, actually. I forgot. Okay. So this is supposed to represent the difference between from the previous pixel, right? So now we just say that their output is going to be prev plus current. I think. Right? Because if before we were subtracting, we add to invert it. Let's see if that what that looks like. We'll panic here. Or unreachable, maybe. For now, and then what's he pissed at? Expected. What the fuck is he complaining about? This he's mad at the filter type needs to be or else panic. Or return error invalid filter type. I guess. I just must have like a fucking bracket wrong somewhere. I just don't know where it is. I don't know where it is. Expected this found that? Hello? Where is it finding? Oh, I put it on from the else. Okay, so this is still clearly wrong, which means that we've done something extremely wrong. And then what the fuck is it printing here? Decompressed data, I see. Am I like just, why am I fucking printing that? Like, get that shit out of here. Okay, so now why are we doing this wrong? Let's check here if sub are we in here at all? Are we in here at all? We are seeing subs. Okay. So then what are we doing wrong here? What are we doing wrong here? At the very least, the output data, unless I'm like missing something in the leaks, can we just turn off the leak checking for now just to try to clean up the output to check if we're actually failing? I don't think we are. I think that it's succeeding. Yeah, he is. So then why the actual fuck is this a problem? So on write we do give me the previous byte and this minus previous byte is the output, which means that to decode we have to add our thing to previous byte, right? Yeah. Which is what we do. We have current is the scanline at the current index, which is the scanline index plus b. Previous is 0, and then we write byte previous plus current. Oh my god. Is it possible that we need to refresh this? No. So what are we doing wrong? It's also interesting that like this feels fat on the left, right? It feels like it's working once, but that's it, right? Like if we do sub here or none, and then we comment out this stuff, does it look different? Like is it common here in this language? It is. Right here, we're seeing 1 pixel on the left, which is like reasonable, right? We're seeing the difference from 0 for the first pixel. But then, if we fix this and we enable this code, we are seeing 2 pixels, which means that the first thing is kind of working, right? The first the first pixel is correctly subtracting itself from the previous pixel, but then every other pixel value is still 0? What the fuck is going on there? We must be doing something fucking brain dead here. We're writing the right amount of bytes, I think. Otherwise, the image would get fucked up, right? If we change this from 0 to 2, right? I think we would just see some like absolute fucking trash, right? Like this, like, right? It gets like totally fucked up. So we're writing this right amount of bytes to the output. And I would like to like invert the image. I bet it's not really all black. Yeah, it should be like 1, right? So let's try to bisect the problem. We know that when we reload the value, the thing we wrote with STB image, we're seeing the right thing, right? Which means that the thing we're encoding should be correct, right? And we can probably get a clue on that if we look at the manufactured ping here. What we should see, oh, it's compressed, fuck. Can we print the decompressed data or like dump it somewhere? Let's just do like a const output decompressed output raw. We'll call it is going to be output raw f or output raw f. Sorry, is stood fs current working directory create file output raw. And can we just be like output raw file write all of decompressed data items, okay? Or decompressed data. I just want to see, like what I expect to see is like line by line, some form of like linear increase in values. Right, so we look at output raw here. Can we do like hex dump? Oh no, wait, maybe that's fine. I would like to see hex dump as grouped as U32s. 2 bytes hex, 2 bytes octal. Can I do like 4 bytes? Maybe not. That's fine. We can leave this that way. Right, so what we should see is like as we go, as we move down, we should see like zeros towards, I guess we should see like a big green number. We should see big numbers every once in a while. So this is 50 bytes long. So we should be able to see it like 50 byte boundaries, or like just at the start here, right? We see here, this is like the first row, which has no sub encoding, right? Then here, we start to see the relative encoding, right? So the first line has like a large alpha value, and then a small red and maybe this isn't it. Maybe it's here. Anyways, we can see here that we're seeing like basically the same like 3 and 2 change over and over and over again, right? The green value. Oh yeah. Hold on. So the green value stays constant for the whole row, and the red value changes. So we're seeing, we're seeing green value change. Maybe it's green changes and red's the same, but we're seeing like a one value change kind of a little bit for every pixel on here, which I think makes sense. So then why the fuck are we not seeing that? Why are we not seeing that? Scanline current. So you have actual color, blah, blah, blah. And you need to get actual color plus 1, actual color plus 1 plus 1. But you decode it as, oh, yeah, you're right. You're right. I am looking at the previous value in the scan line, but I have to like accumulate as we go. You're very correct. Thank you. So here we have to do like accumulator equals 0. Okay. And then we say previous is 0. Otherwise, we look at this thing. And we shouldn't actually be looking at previous here. We should be looking at the accumulator. Oh, but we need an accumulator for the previous byte. So maybe we don't look at the accumulator. Maybe we look at the output, which we have not stashed anywhere, which is why we had the accumulator. Fuck. So we need like this is like the fix for now. We have 3 U8s equals 0, and then we have ACK B. Yeah. So we have ACK B plus equals current minus priv, which means that we probably want this to be like I16s, probably. And we probably want to cast these to I16s unless things can only get brighter. Are these... What happens if these things are supposed to be like signed, like unsigned integers? Oh, here we go. Unsigned arithmetic modulo 256 is used. Oh, so we just do wrapping adds. So we just put a percent here. So it's supposed to be like something like this. Right? Right? LOL QTalks user detected. I'm personally offended. How did you know? I haven't used QTalks in a while. Oh my god, it's Greyheader. Wait, is this? I seem to remember. Yeah, UTalks Greyheader from the Talks IRC. I think I wasn't really around in the IRCs, but my friend was around in the Talks IRCs all the fucking time. My friend recognized your name on some issues. That's funny. That's funny. Yeah, back in the day, I haven't worked on Talks for a long time. Is it alive? In my mind, it's kind of dead. I worked on Q Talks back in the day. Oh, and that explains why you're saying Q Talks users. Like, it's super dead. Yeah, that makes sense. I worked on this a lot back in the day. But because I needed to I wanted to talk smack at work. And I didn't want to talk smack on the company channel, right? Because like then they would have record of it. That's bad. But I didn't want to leak any information about the company externally because I think that also violated company rules. So we got into talks because we were like, well, the data doesn't leave the network, right? We can even point at each other locally. And then we tried to use QTalks, and it was just so fucking broken that we just had to start fixing it. There was no choice. The only good client is ATalks. Everyone knows this. ATalks is Robin Lee's Android client, I think. Right? I talked to that guy a little bit. Yeah, ATalks is pretty sick. Still in development. That's crazy. I should have used UTalks. I think we tried it and for some reason considered it worse, but I shouldn't say that out loud because you'll get mad. I think that probably the feature list or something about it seemed like made QTalks seem more appealing, but maybe QTalks seemed more appealing and then was broken to shit when we started using it. He's got big frowny faces. That's so funny. All right. Focusing the fuck up. Does this thing work now? No, because right, obviously this needs to be 3 I16s of 0 like this, I think is how you do this. Okay, now right byte ACK. Oh no, this needs to be U8 still. We're just using modular arithmetic. All right. Still broken as fuck. God damn it. So it's because this is still fucking wrong. Previous should now be. No, wait, this is right. We add the difference between me and the previous, but that's not right. Yes, it is. Fuck. So we go like 0, 1. We have like, you know, an initial big spike, 50, right? Then we have like 3, 3, 3, 3, 3, 3, 3, right? And so this is supposed to turn into 50, 53, 56, 59, 62, etc., right? So our accumulator starts at 0. We get this first big spike, current minus prev should be 50. Then on the next iteration, current minus prev, we'll see 3, 3, 3, 3, 3. We'll see. No. Wrong. Wrong. We only need to look at current. We don't need prev at all. Prev is useless to us. Aha. Am I? Oh? Let's go! Let's go! That's fucking sick. All right. So sub finally implemented. And now that we understand a little bit better, hopefully the next pieces will be a lot simpler to implement. So filter type up is, you actually need to use the act. I was using it. I just wasn't using it right. Okay, up filter is just like sub, except the pixel immediately above the current pixel rather than just the left is used as the predictor. So to compute the up filter, we do the following. Okay, so let's try to manufacture something that has ups in it. Can we do? So we'll just add a 3 in here, and then can we do? Stood meta enum int to enum of filter type here. We'll call this filter type. And then I guess we want int from enum here. Okay. And now here we can start using like none. We can use sub here. Why is it sub if you don't use sub to get the result? You use sub to get the value though. Right, so to calculate this thing, you do out is this minus previous, so that's why it's called sub. It's on the it's based off the encoder, not the decoder. If that makes sense. Okay. So now I think we're hitting this else unreachable because we changed this to 3. If we have this at 2, can we go back? Okay, so we're chilling. Everything's happy. Let's keep moving. Okay. Add back the 3, and we need to add up here as an option here. So here, surely we're going to go over the scan line. And we have the out row this. The previous is now just going to come from like the previous row. Right? So we're going to have to figure this out. So this is going to be like if out start is less than scanline size, we're going to do something. Else, okay, can we do like, I want like a function. I want a function. So we want to do like a previous row. Ugh. So we're going to take like the data. Right. And we're going to have like the start and the stride, I guess. I don't know, man. I don't know. And so we're going to say like if start is less than stride, I guess it's going to return like an optional. Or return null. Then otherwise, we return data from start minus stride. So start? Yeah. That feels right. And so now we should be able to go like previous row is equal to previous row given our like pixel buffer data out start and scanline size, I guess. And we're gonna subslice it from 1 onwards because 1 dot dot to remove previous scanline header. But we don't want, we only care about like the output row. We want to remove previous input row. So how does that work? We have in row pixel U8. This is image data here. So can we do this? Image row start is equal to, I don't know, this. Image row end is equal to image row start plus width. Okay. Okay. Which means that down here, if we're trying to look at the previous row, we actually don't want like data's U8. We kind of want data as like an any type, I guess. And this is gonna return like a question mark type of data, I guess. I don't know, man. And then we're gonna be like image row start and width here. Okay, there we go. And then we can go previous row U8 is a stood mem as bytes. Previous row. Except that we have to be careful. Otherwise, we have to basically like could say that these things are 0 because this previous row might not exist. So we don't do like if previous row. I don't know, man. Like, is this allowed? I don't know, man. Then here we go, like const previous val, previous byte is like if previous row U8, then we look at previous row U8 at XB, right? Else 0. And like really, we should just separate these cases completely. Right? So we can actually do this. We can do or else we can do like if previous row, we do all of this shit, right? This is like stood mem as bytes p like this. Yeah. So we look at the previous row. If the previous row is there, we kind of like do the calculations. Otherwise though, we just go like we do the same loop, I guess. But we just write x in pixel row U8 xb. Sure. That seems like possible if that's right. I'm not like 100% sure that's going to be wrong. He's mad about integer overflow. I think you just have to do wrapping sub here. And then previous row U8 here is failing. So what the fuck have I done wrong here? What have I done wrong here? This is supposed to go start minus stride to start. Okay. So we have start and width. And this is in pixels. Okay. Then we take this thing. Why is he falling over then? Out row U8. Oh wait, no, it's not that one. It's previous row U8 at this byte position. Yeah, I don't really understand why this doesn't work, to be honest. I do not understand why this doesn't work. Can we GDB? What are we looking at here? What are we looking at here? We have XB here is 1. Okay. That's not good. What the fuck? Image row start 200. Width doesn't exist. Okay, previous row. Len 100. God damn it. It's slices bytes, not as bytes, and I get this wrong so fucking often. Fuck. God damn it. Slice as bytes. It shouldn't fucking work. It shouldn't work for me to get it that wrong. Okay, index out of bound. Index 100, length 100? Okay. Yeah, slices bytes. What have I done wrong now? What have we done wrong now? Previous row U8 has length 100. Previous row also has length 100, so surely that's wrong, right? Surely that's wrong, right? If the width is 100, then the slice as bytes should have a length of 400? Like, am I fucking mental? What the fuck have I done wrong? Previous row, he returns the same thing, right? So can we look at like previous row is length of this. I wouldn't use as bytes here. I'd use either do you, but the encoding is on a byte by byte basis, not on a pixel by pixel basis. Can we look at previous row len here? These switches are pretty wild. Yeah, I mean, these are going to get better. Like, I'm going to have to refactor a lot of this later, but I'm just kind of like in prototype now, we call it. You know? So, it is what it is. I just want to make sure I'm not like fucking mental. Okay. Yeah, so we have the U8 size and the like non-U8 size are the same. That's insane. Unless the type of previous row is like fucking bullshit. Oh, it's god damn it. This is why I need to refactor. Because we have data and image data. And we're just using the fucking both of them. God damn it, god damn it, god damn it, god damn it. Okay. So now, how does this look? Okay, that's fucked up for sure. But what about test manufacture.ppm? So this is still looking okay, which is a good sign. Let's just make sure that if we remove test manufactured ppm, let's just make sure that thing is still there. Yeah, so he comes back and it looks correct. And let's just confirm now that if we do something fucking dumb, stupid, dumb, right? Like we don't subtract, for example, that it looks fucking stupid, dumb, stupid, like we expect, right? And it does. Okay, so we are seemingly correctly implementing the up variant because it doesn't look like shit. So now we just have to make it that we process the ups version as well. Not yours, just how Zig handles that. When the program starts to grow, they're going to get in pretty quick. I mean, I agree. And I think that's not Zig's fault. I think that's my fault. Right? Like, that's just how switches work, right? If you have things and you're doing lots of stuff, like the way you should do this, right, is you should do switch filter type and you have like none and you go handle like filter like executor handle none with data or something, right? And then you do like sub and you do handle sub, right? This has nothing to do with like Zig and their switches, but it has everything to do with the fact that we're not organizing our code in any way, shape, or form. And again, we will fix that later. Okay, so this is going to look pretty similar, I think, to the previous subcase. But our accumulator is still going to be on a... Our accumulator has nothing to accumulate, right? If we're going on a line-by-line basis, we don't have the same problem where we're like stacking increases because the previous line will exist by the time we get here. And so it should be like legal for us to just look at the previous line's value. So we just need to do the same thing here where we have like previous row, and this is gonna have to come from something, right? So where is our like decompressed data? No, we don't want to look at that. We want to look at like our output data, which doesn't really exist. Interesting. Interesting. So maybe we just have to actually buffer the data. I was kind of trying to avoid this like intermediate representation, but it seems not really possible. I guess you could edit the thing like the decompressed data inline, right? Because we have like PNG to compressed PNG data to scan lines with filter types to fixed RGBA image to PPM, right? And I was trying to skip this step, this like fixed RGBA image. But if we're trying to like look at the previous row, like we can't do this like accumulator trick anymore, right? If the previous row is not like available to us, we can't look at it. But we could, instead of like writing out a new thing, we could just fix that shit in here. So as we like walk each scan line, we heal the data in it so that we can look at it in the future. And I think that might kind of solve our problem for now. So instead of using this accumulator, fuck the accumulator. Instead, we look at the previous index again. Minus bytes per pixel here. And current is equal to this. And then we say that here we have to be careful. How do we do this? Current IDX is greater than bytes per pixel. Here we're gonna have to like, no, I guess it's fine. We do prev is equal to, we were there. God damn it. Prev is equal to if current index is less than or equal to bytes per pixel, we look at, dude, my poor little brain. Scan line at current index minus bytes per pixel, else 0. Okay. Then, instead of writing accumulator here, we just write scan line at current IDX is equal to prev plus current, and then we write the byte at scanline current index, which now makes it so that now we can look at the previous scan line and it's like fucking chilling, right? So we look at the scan line start. So we look at previous row. We're looking at the output data here, which we have called, or the input data, I guess. So we have scan line as decompressed data. Okay. So we're looking at decompressed data from scanline start and scanline size. And this should give us the previous row. Okay. And then we're going to do like a similar, we're going to say if previous row we have a row to look at. Else, we do not. And if we do not, we're just going to do this, right? Whatever we were doing in like... Oh, we just look at the line as is. Fix me dupe with none case. But if we do, we're gonna like iterate by index, I think. So we're gonna go like for 0 scanline size -1 because we have to filter out we have to filter out the filter method, and then we're just gonna go try writer write byte of prev plus current, right? With a wrapping add, which I guess probably means that this probably also needs a wrapping add. And then we just need to get prev. So prev is equal to the scanline, the previous row. I think we want to go from 1 to scanline size because that makes the previous row indexing really simple. So we can just go previous row scanline IDX like this. And current is equal to the current row. Seems good to me. Syntax-wise, what hurts my eyes the most in Zig is the const/var. Can't these be inverted keywords? And the @cast syntax. Also, the empty dot squiggly braces isn't very obvious. But I have no experience with Zig, just first impressions. Yeah, I think that, I mean, I'm willing to, hold on. Hold on. I'm willing to put up with that type of shit because, like, I think that, like, syntax in general is just kind of like familiarity, right? So it's like, yeah, sometimes things are a little bit odd when you've seen them the first time, but it's just kind of the way it is as well, you know? And you'll get used to it, so I don't really mind. Isn't const inferred? I don't think that you can infer const and var, by the way. I think that there's like a very intentional, I want this thing to be const and I want this thing to be mutable, and like specifying that is important. They infer the types, but I think that like it's important to write them down. I kind of think that's good. Oops, greater than or equal to bytes per pixel is what I meant to do here. Okay, so we have alternating subs and ups, which is pretty good. And then if we open what we just fucking wrote, we suck balls. So we can see that the first 2 lines are looking okay, right? We have gradients here, but then as soon as we hit the first up line, actually, I'm kind of confused here. What are we seeing? This seems like it's like the none, left, up, and then the none case here gets fucked. Oh, we're probably not writing enough bytes. We're probably not writing enough bytes because here you're seeing like a misaligned next none line, right? Which means that we're writing too much in the up case. Is kind of how it feels. It does kind of feel that way. So what is supposed to be happening here? We're supposed to have scanline. Is scanline start to scanline end? I'm assuming this isn't happening, right? I'm almost positive this branch is not being hit right now. Yeah, it's not. Oh, oops, sorry. That's a lie. Yeah. And then can we actually confirm here that if we do, or do we like %3, let's just make sure that if we remove the upcase, that everything is still working, because we did change it a little bit. Yeah, so if we look, it's only having the none filter and the left filter, we're chilling. So it's definitely the application of the up filter. And let's just double check again that when STB image interprets our PNG, it's looking okay, right? So the reasonable assumption here is that there's some bug here. That's the reasonable assumption here. Okay, so we look at our we go over our scan line. Oh, we have to fix ourselves, which we're not doing, but like maybe that's not a problem, although we should do that. What is like the type of this? Oh. This is pixels. So that's a good clue. That is a good clue. Now, why is that? Decompressed data is like this. Are we using like decompressed data from scanline start to scanline end? Scanline size is width times width per pixel. Okay. Yeah, so decompressed data shouldn't be by pixel. I think this is wrong. I think the language server is wrong here. Previous row type is this. And this should be type name of previous row. Let's just get a clue here because it's fucked. Something's wrong. Type of this. Yeah, so this is a question mark U8, which makes sense. What am I missing here? Scanline size is width times bytes per pixel plus 1. Yeah. Oh, because write byte is supposed to write 3 bytes. God damn it. I forgot. I forgot. So we have to do it this way. We have to do it this way. I forgot. I forgot. Okay. Was that better? Oh, hell yeah, baby. Let's go. Let's go. Up filter working correctly. Let's go. Okay. So we have sub and up working okay. Then average and path. And it looks like these I think are more complex than the other ones. I think. Oh, RWX Rob, thank you for the raid. Late for dinner, have fun. All right, bye. We are having hello RWX Rob viewers. We are working on a PNG decoder. We've gotten reasonably far here. Reasonably far. We kind of have like the overall structure stubbed out. The code is absolute shit. We'll fix that eventually. But we're kind of just like prototyping right now. So our pipeline is we open a PNG image, we try to read it, we try to write out this like PPM file format, and we just like eyeball it and check if it's right. So what we've done right now is we're manually constructing a PNG. And the PNG file format is essentially like you have a header of some form. It has things like the width, the height, the bit depth, the color type, and stuff in there. There is like a data segment, and then like an end segment. There's like other chunks that could be in there, but really it's just like header, data, end is like the stuff we're looking at right now. And in the data segment, you have like a zlib compressed chunk of data. So we like open that up. We haven't quite managed to open that with our own zlib decompressor yet, but we are getting there. We're for now using real zlib to do that decompression. But where it gets interesting is that the data in that thing is a little bit odd. It's like each line of the image has like a prefix on it, and that prefix says what type of filter is applied to this thing. And the reason they do that is because if you have like a line that is like very similar color, or like a line that's like similar to the line above it, if you encode each pixel as the difference from the previous pixels of this one, you will have much more compressible data, right? Because you'll essentially have like a row full of like values very close to 0, and if they're all like 0, 0, 0, 0, or like 1, 1, 1, 1, or 2, 2, 2, 2, or whatever, that compresses very, very, very well. And so what we have been doing is we have been writing a PNG encoder to go along with our decoder just for testing. So we have figured out how to handle 3 of the 5 filters. Right, we have here are the 5 filter types defined by the specification. So we have handled none, which is just like read the pixel data as is. There is sub, which is like basically compare me to the value on my left, and up, which is compare me to the value above me. And we have successfully, look, that's not fucked up. So big win for us. And unfortunately, you guys raters just came in at like a really unfortunate time. I was about to say, it's 4:15, and I suspect that this average and payeth filters are more complex than the previous ones we've been working on. Right, so we have in the RFC, average is usually the average of 2 neighboring pixels left and above. Okay, so that one's fine. That should be pretty straightforward. Although this will take a little bit of fiddling to confirm. And then there's this like payeth thing, which computes a simple linear function of the 3 neighboring pixels, left, above, upper left, and then chooses the predictor of the neighboring pixel closest to the computed value. This is like, it's like, I don't know what the fuck is going on. Like, what is this? And so I was going to say, this is enough stuff that it is worth like stopping for today and coming back tomorrow, because I try to stream only till around 4 o'clock Pacific time. It's 4:15 now. And so I don't want to go too long. So apologies, raiders. We're going to forward you on to someone else, but I thought I would give you a little preview of what we're working on, just so that if you want to come back, feel free. We'll be back on tomorrow at around 2 o'clock Pacific time is when we start working on this again. But yeah, for the rest of you, thank you for watching. I hope you like what you saw. If you did, we stream most days at 12:30 Pacific time to 4 o'clock Pacific time. 12:30 to 2, we do like we could do this like segment called Happy Hour, where essentially if you looked at what we wrote today and we tried to commit that and use it in the future, we would be like, ugh, gross, that's disgusting. I'm never writing code with this guy, right? So we need some time to do some like cleanup, unit testing, refactoring, whatever, maybe like reading about stuff. So basically like 12:30 to 2 is kind of like supplemental content, stuff that is not really important to follow progress of the project, but is important to have a finished product. 2 to 4 is what we call mainstream, and that's what you're seeing right now. So if you want to check that out, there's a YouTube link in the Twitch description where all of the archives of the mainstream go. The happy hour streams are archived in YouTube members streams or on Patreon, so there are links for that if you want to check those out as well. There's a GitHub link in the Twitch description. I will make a repo called libimage. Probably I will commit it. The first commit will probably be like a fully fledged working PNG decoder, so, or at least one that isn't like garbage. So probably the first clean checkpoint is what will go in there. It doesn't exist yet, but it will go up eventually. What else? Like, subscribe, Twitch Prime. You guys know the deal. I guess that's it. YouTube, goodbye, and Twitch, let's find someone to raid.